What's up YouTube? Today I will be showing you how to program your Arduino to read encoders, and this is going to be the schematic of the system. So any encoder will have 4 pins: VCC, ground, the encoder A pin, and the encoder B. So you have to check your data sheet of your encoder and find out the required voltage, the power supply. So in my case, I have a 5 volt encoder. So I'll be providing that using the 5 volt pin in the Arduino, and you have to connect the ground. And by any chance, if you are providing the power to the encoder using an external power supply, make sure that the ground of the external power supply is connected to the ground pin of the Arduino as well. And encoder A and encoder B wires should be connected to pin 2 and pin 3 of your Arduino Mega. And even if you are using an Arduino Uno, connected to those 2 pins. The reason that I am telling this is because in this program we'll be using interrupts to read the encoder values. So to use interrupts, even though you have many digital pins in your Arduino board, there are only a few interrupt pins in each board. So in the Arduino official website, they have listed out the respective interrupt pins for each board. In this tutorial, I'll be using a Mega. So I'll be having these 6 interrupt pins. So depending on your board, find out the respective digital pins for your board, uh, and connect it to one of the 2 of the digital pins available for your board. So going back to the program, first off, we have to declare some variables. Uh, uh, one, first you'll have to declare your encoder pins. The That means the encoder A and encoder B wires, the pins you have connected, the encoder A and encoder B wires. And then the reason which why I have used the constant part is because to make sure that you won't change the value of this variable. It's not necessary, but it's considered good practice. And then uh, you have to declare, you have to check your encoder datasheet and find out these values. The PPR is known as the pulses per revolution. That means how many pulses it produces when it travel one whole revolution. And this gear ratio, uh, it actually depends on your encoder. What I mean is that if it is attached to a motor, you'll be able to find the gear ratio in the data sheet. But if your encoder is a standalone device, then your gear ratio will be 1. And then your the decode number. What I mean by the decode number is that you can actually, using a program, uh, you can actually um, change the resolution of your encoder using the software. So I'll be using 4x encoding. 4x encoding means that you are multiplying your current resolution of your encoder by 4 times. So you are increasing your resolution 4 times. Then and then you have to declare one more variable. That's the variable we use to record uh, the pulse count of the encoder. So it will be a volatile long int. So volatile, when you declare as a volatile variable, it will be saved to your RAM buffer, and basically this volatile variable is used when you have a variable which is used in a separate thread other than your main program. And since, as I said before, I'll be using an interrupt which is a separate thread from the main program, and I'll be using this variable in the as the interrupt variable. So I'm declaring it as volatile. It's important to declare it as volatile, and long is when you have increased number of bits per for that variable. And let's start the program. And you need to declare two more methods um, to, let me just show you. You have to declare these two methods which will be used to increment or decrement the current position variable depending on the signal uh, received. So I'm not going to go and explain the theory behind this. If you want, you can drop it down in the comment section below, and I'll be happy to make another tutorial explaining the theory behind this, how we come up with this algorithm. So for now, I'll be only explaining the programming part, and then there are a few things which goes into the setup. First thing, we have to declare the encoder pins. It should be all capital. So usually we define it as an input, but in this case I have used input pull-up. What it means is that the Arduino will use its internal resistors to make a pull-up circuit for this pin. And but if because it's a good practice to always pull up the A and B pins of the encoder, but if you are using a hardware pull-up circuit before connecting it to the Arduino, then you don't need the pull-up section. You just have to declare it as input. But since I'm not using a hardware circuit, I'm just going to use the inbuilt resistors available in the Arduino. And so I'll be explaining the rest of the tutorial in my next video. So make sure to click the link at the end of this video to see the rest of the code.